Dear students, we are discussing magnetism in last class and field intensity, magnetic field, field intensity hidden position, broadside hidden position, etc. Today we shall discuss about different magnetic substances. Before going to discuss different magnetic substances, let us define some terms associated with them. So the first term will be your magnetic induction. Magnetic induction. Magnetic induction. Normally magnetic induction denoted by letter B. Magnetic induction. What does it mean by magnetic induction? When there is a magnet, it has a magnetic field around it, and a magnetic field is characterized by magnetic lines of force. You know what are magnetic lines of force? I have already discussed the properties of magnetic lines of force. So magnetic induction at a place in a magnetic field is defined as the number of lines of force per unit area when the area is normal to the direction of flow of flux. That is definition of magnetic induction. So magnetic induction, you can remember the definition. Magnetic induction at a place, at a point in a magnetic field is defined as the number of lines of force, per unit area, when the area is normal to the direction of flow of flux. So this is the definition of magnetic induction. That means very simple way, magnetic induction is magnetic lines of force per unit area. Next is intensity of magnetization. Intensity of magnetization. It is denoted by letter I, intensity of magnetization. So when there is a magnetic field, at a point you can measure what is the intensity of that field, whether the intensity is large or intensity is small. How it is defined? It is defined as the magnetic moment per unit volume. Intensity of magnetization is defined, as the magnetic moment per unit volume of the magnet. Magnetic moment per unit volume of the magnet. You know what does it mean by magnetic moment and what is the volume of the magnet. Let us find out those things. What is the magnetic moment? I have already told you magnetic moment is defined as the product of pole strength and distance between the two poles. That is, magnetic moment is it is denoted by capital M, which is equal to M into 12. What is to M is pole strength, 12 is the distance between the poles. M is pole strength, is distance between the poles, which we have already discussed in last class. Distance between the poles. So this is your magnetic moment. So what is your intensity of magnetization? I is equal to what? Magnetic moment per unit volume of the magnet, M by V. Magnetic moment per unit volume. And your magnetic moment is M into 12. And volume of the magnet is what? 12 into A. What is A? Where A is area of cross section. Where A is area of cross section. Of the magnet. So 12 cancels. This becomes what? 12 will cancel, this becomes m by a. M by a means pole strength by area. So the intensity of magnetization can be further defined as the pole strength per unit area. So intensity of magnetization you can define as the pole strength per unit area or magnetic moment per unit volume of the magnet. Now let us go to next definition, which will be required for different magnetic substances. Magnetic permeability. Magnetic permeability. Magnetic permeability. It is denoted by the letter mu. What does it mean by magnetic permeability? How a substance permits magnetic lines of force to pass through it. If the permeability will be more, the substance can be more magnetized. It is defined as what? It is defined as the ratio of magnetic induction to the magnetizing field. It is defined as the ratio of magnetic induction symbol is B, to the magnetizing field, or it is also defined magnetizing field, that denoted by H, magnetizing field. You can also call it magnetic permeability, magnetic induction per unit magnetizing field, So mu is equal to what? Mu is equal to B by H. Permeability is equal to B by H. This is magnetic permeability. Next is magnetic susceptibility. Next definition is very important. Magnetic susceptibility. How far the substance is susceptible to a magnetic field, that is your magnetic susceptibility. It is denoted by the letter chi, or you can also denote it by K, magnetic susceptibility. It is defined as what? Defined as the ratio of intensity of magnetization to the magnetizing field. It is defined as the intensity of magnetization per unit magnetizing field. Intensity of magnetization per unit magnetizing field. Intensity of magnetization symbol is I, magnetizing field symbol is H. It is defined as the intensity of magnetization per unit magnetizing field. So you can denote it by chi or K. Symbol is chi or K. It is equal to what? I by H. Intensity of magnetization to the magnetizing field, I by H. So magnetic induction, intensity of magnetization, magnetic permeability and magnetic susceptibility. We will use all these terms in properties of different magnetic substances. Different magnetic substances. Different magnetic substances. Different magnetic substances. How do you classify the magnetic? What is a magnetic substance? You know, a magnetic substance is that substance which gets affected in a magnetic field. Depending upon the behavior of a magnetic substance in a magnetic field, all the magnetic substances are classified into three types. So depending upon the behavior of a magnetic substance in a magnetic field depending upon the behavior of a magnetic substance in a magnetic field. Magnetic substances are divided into three types. Magnetic substances are divided into three types. We will discuss the substances one by one. There are three types of magnetic substances. What are the three types of magnetic substance? One is diamagnetic substance, second is paramagnetic substance, third is ferromagnetic substance. One is diamagnetic substance. Number two, paramagnetic substance. Number three, ferromagnetic substance. The three types of magnetic substances are very important from examination point of view. You may get a long question from this or there are a number of short questions from this also. So, we will discuss the properties of diamagnetic substance, paramagnetic substance, ferromagnetic substance one by one. Diamagnetic substance. What is a diamagnetic substance? Diamagnetic substance. What is a diamagnetic substance? A diamagnetic substance gets repelled in a magnetic field. It will not be attracted, it will be repelled in a magnetic field. Remember that is very important. A diamagnetic substance gets repelled in a magnetic field. Remember it. Gets repelled in a magnetic field. What are the examples of diamagnetic substance? Some examples are there: bismuth, antimony, etc. Bismuth, antimony, etc. A diamagnetic substance gets repelled in a magnetic field. Example: bismuth, antimony, etc. Now let us discuss the properties one by one. There are some 8 to 9 properties. We will discuss the properties one by one. These are important for long question and also for short questions. Properties of diamagnetic substance. What are the different properties of a diamagnetic substance? Let us discuss the properties one by one. The first property is a diamagnetic substance gets repelled in a magnetic field. That is very important. A diamagnetic substance gets repelled in a magnetic field. Number two, when it is allowed to move in a magnetic field, it moves from stronger part to the weaker part of the magnetic field because it gets repelled. So, it moves from stronger part to the weaker part of the magnetic field. It moves from stronger part to the weaker part of the magnetic field. Third property, when a diamagnetic substance is magnetized, magnetization develops in a direction opposite to the magnetic field. When magnetized, magnetization develops in a direction opposite to the magnetic field, opposite to the magnetizing field, opposite to the magnetizing field. When magnetization develops in a direction opposite to the magnetic field. Next, fourth property. As you know, permeability mu is V by H. Permeability. What is the permeability of a diamond substance? Permeability of a diamond substance is positive but less than 1. Permeability of a diamond substance, permeability of a diamond substance is positive but less than 1. Positive but less than 1. Mu is positive but less than 1. Remember this, less than 1. Mu is positive but less than 1. So, susceptibility. What about the susceptibility of a diamond substance? Susceptibility of a diamond chi, I by H. Susceptibility. Susceptibility of a diamond substance is negative. Susceptibility of a diamond substance, susceptibility of a diamond substance is negative. Susceptibility of a diamond substance is negative. Next, how does the susceptibility of a diamond substance depend upon temperature? Next is susceptibility of a diamond substance. Susceptibility of a diamond substance. Susceptibility of a diamond substance is independent of temperature. Is independent of temperature. Doesn't depend upon temperature. Susceptibility of a diamond substance doesn't depend upon temperature. Next, when a diamond substance in the form of a rod is suspended in a magnetic field, it remains perpendicular to the magnetic field because it is repelled. When a diamond substance in the form of a rod is suspended in a magnetic field, when a diamond substance in the form of a rod is suspended in a magnetic field, it remains perpendicular to the magnetic field. It remains perpendicular to the magnetic field. It remains perpendicular to the magnetic field. That you can show like this, North Pole, South Pole, it will remain like this, perpendicular to the magnetic field. Next property. When a diamond substance is powder form taken in a glass is kept in a magnetic field, elevation occurs at the middle with the depression at two sides because a diamond substance gets repelled in a magnetic field. When a diamagnetic substance in powder form taken in a watch glass is kept in a magnetic field, is kept in a magnetic field when a diamagnetic substance in powder form taken in a first class is kept in a magnetic field, elevation occurs at the middle with the depression at two sides. Elevation occurs at the middle. Elevation occurs at the middle with depression at two sides. Because a diamagnetic substance gets repelled by a magnetic field, like this diagram will be like this. Elevation occurs here. Next property. If you take a diamagnetic substance liquid form in a U tube and keep it in a magnetic field, then what will happen? Because it is repelled by a magnetic field, depression of the liquid column takes place in the limb kept inside the magnetic field. So when a diamagnetic substance, a liquid form taken in a U tube is kept in a magnetic field, depression of the liquid column takes place in the limb placed inside the magnetic field. When a diamagnetic substance in liquid form taken in a U tube is kept in a magnetic field, depression of the liquid column takes place in the limb placed inside the magnetic field. Depression of the liquid column takes place in the limb placed inside the magnetic field. The diagram will be like this. There will be depression here. This side will go off like this because it gets repelled in a magnetic field. Next. Mu is positive but less than 1. Mu is equal to B by H. Therefore, B is always less than H. Mu is equal to B by H. Since mu is positive but less than 1, mu is positive but less than 1, B is always less than H for a diamagnetic substance. So these are some properties of diamagnetic substance. The most important properties of a diamagnetic substance is diamagnetic susceptibility is negative and diamagnetic susceptibility is independent of temperature. These are two important properties. Remember the property. Next we will go to paramagnetic substance. Paramagnetic substance. What is a paramagnetic substance? A paramagnetic substance gets weakly attracted in a magnetic field. Diamagnetic substance gets repelled. paramagnetic substance gets weakly attracted in a magnetic field. A paramagnetic substance gets weakly attracted in a magnetic field. Weakly attracted in a magnetic field. Examples: aluminium, chromium, manganese, etc. Aluminium, chromium, manganese, etc. are the examples of paramagnetic substance. Properties of a paramagnetic substance. What are the different properties of a paramagnetic substance? Properties of a paramagnetic substance. As we have got properties of diamagnetic substance, similarly there are properties of paramagnetic substance. In the examination, there may be long question, compare the properties of diamagnetic substance and paramagnetic substance. That will make a long question. So the first property is, a paramagnetic substance gets weakly attracted in a magnetic field. That is the first property. A paramagnetic substance gets weakly attracted in a magnetic field. This is the first property. Second, diamagnetic substance moves from stronger part of the magnetic field, but paramagnetic substance moves from weaker part to the stronger part of the magnetic field. A paramagnetic substance moves from weaker part to the stronger part, because it gets attracted, moves from weaker part to the stronger part of the magnetic field. Weaker part to the stronger part of the magnetic field. Third property. When a paramagnetic substance is magnetized, the magnetization develops in the direction of magnetic field. When a paramagnetic substance is magnetized, when a paramagnetic substance is magnetized, the magnetization develops in the direction of magnetizing field, in the direction of magnetizing field. Next property, fourth property. About permeability. Permeability of a paramagnetic substance is greater than 1. Greater than 1 is obviously it is positive. So permeability of a paramagnetic substance is more than 1. Mu is more than 1. Obviously, it is positive. Mu is positive, more than 1. Permeability of paramagnetic substance is more than 1. Clear? Mu is equal to B by H. Since mu is more than 1, B must be greater than H. Since mu is more than 1, B is more than H for a paramagnetic substance. For a paramagnetic substance. paramagnetic substance. Next. So, this is regarding your permeability. Next will be regarding your susceptibility. Susceptibility of a paramagnetic substance is positive but less than 1. Susceptibility of a paramagnetic substance is positive but less than 1. Susceptibility positive but less than 1. Chi is less than 1 but positive. How it depends upon temperature? Diamond is susceptible independent of temperature, but when a paramagnetic susceptibility is inversely proportional to absolute temperature. Susceptibility is a very important property. Susceptibility of a paramagnetic substance is inversely proportional to the absolute temperature, inversely proportional to the absolute temperature. This is a very important property. Chi is proportional to what? 1 by T, or chi T is constant, This is called, remember this is very important, this is called Curie law of paramagnetism. Curie law. Susceptible of paramagnetic substance inverse proportional to absolute temperature. Next property, when a paramagnetic substance in the form of a rod is kept in a magnetic field, it remains parallel to the magnetic field. Diamagnetic substance remains perpendicular to the magnetic field, but a paramagnetic substance remains parallel to the magnetic field. When a paramagnetic substance in the form of a rod is suspended in a magnetic field, it remains parallel to the magnetic field. Parallel to the magnetic field. Like this. It will remain parallel to the magnetic field. Similarly, in powder form, if it is taken, when a paramagnetic substance in powder form taken in a glass is kept in a magnetic field, elevation occurs at two sides with the depression at the middle, because a paramagnetic substance is weakly attracted by a magnetic field. When a paramagnetic substance in powder form taken in a wash glass is kept in a magnetic field, When a paramagnetic substance in powder form taken in a watch glass is kept in a magnetic field, depression occurs in the middle. Depression occurs at the middle with elevation at two sides. With elevation at two sides. There will be elevation at two sides. The diagram will be like this: North Pole, South Pole. We'll take a watch glass, paramagnetic substance. Depression at the middle with elevation at two sides, because it gets attracted by a magnetic field. So this is solid form, this is in powder form. Next will be liquid form. If you take a paramagnetic substance in liquid form in a U tube and keep it in a magnetic field, elevation of the liquid column will take place inside the limb in the magnetic field. Just opposite of diamagnetic substance. When a paramagnetic substance, when a paramagnetic substance in liquid form taken in a U tube is kept in a magnetic field, elevation of the liquid column takes place in the limb, kept inside the magnetic field, Elevation of the liquid column takes place inside the limb, kept in the magnetic field. In diamagnetic substance, it was depressed. Here, the liquid column will be elevated because it is attracted like this. So these are the properties of a paramagnetic substance. Next we will go to ferromagnetic substance. Ferromagnetic substance. What is a ferromagnetic substance? A ferromagnetic substance gets strongly attracted by a magnetic field, so it can be converted to permanent magnet. A ferromagnetic substance gets strongly attracted by a magnetic field. A ferromagnetic substance gets strongly attracted by a magnetic field. Therefore, ferromagnetic substances can be converted to permanent magnets. Examples, very simple examples are there: iron, cobalt, nickel, etc. Which can be converted to permanent magnets. Properties of a ferromagnetic substance and similar to those of paramagnetic substance, but exhibited same properties are there, but exhibited to a greater degree. Properties of a ferromagnetic substance. Properties of a ferromagnetic substance. Properties of a ferromagnetic substance. Properties of a ferromagnetic substance are similar to those of paramagnetic substance, but exhibited to a greater degree. Properties of a ferromagnetic substance, same properties but greater extent. Ferromagnetic substance are similar to those of paramagnetic substance, but exhibited to a greater degree. So in those instances, because same properties are there, but they are exhibited to a greater degree. Only one important characteristic I will tell you, that is your Curie temperature. What is Curie temperature? Curie temperature. Curie temperature. What does the examination may get question? What is Curie temperature? When a ferromagnetic substance is heated, its susceptibility decreases. At a particular temperature, a ferromagnetic substance becomes paramagnetic. That particular temperature is called Curie temperature. When, it's very important, when a ferromagnetic substance is heated, its susceptibility decreases. As you know, if you heat iron, its magnetic properties will decrease. When a ferromagnetic substance is heated, its susceptibility decreases. At a particular temperature, a ferromagnetic substance becomes paramagnetic. At a particular temperature, when a ferromagnetic substance becomes paramagnetic, this temperature is called Curie temperature. Remember, this is very important, Curie temperature. When the substance is cooled again, ferromagnetic properties will be regained. If the substance will be cooled, ferromagnetic properties will be regained. Ferromagnetic properties will be regained. So this is a very important thing. What if examination may get question, what is the Curie temperature? So Curie temperature is the temperature at which a ferromagnetic substance becomes paramagnetic, because if you heat a ferromagnetic substance, its susceptibility will decrease. At a particular temperature, a ferromagnetic substance becomes paramagnetic. This temperature is called Curie temperature. If you cool the substance, ferromagnetic properties will be regained again. Again the substance will be ferromagnetic. So this is about your different magnetic substances and their properties. Next we will go to earth magnetism. Or that is also known as terrestrial magnetism. Earth magnetism or terrestrial magnetism. Students, as you know, Earth is considered as a magnet. Why Earth is considered as a magnet? because if you suspended a needle magnet, it will show a particular direction. The north pole of the needle magnet will remain towards geographic north of earth. South pole of the needle magnet will remain towards geographic south pole of earth. Because the geographic north pole of earth contains magnetic south polarity, and geographic south pole of earth contains magnetic north polarity. So earth is a magnet and it has got different characteristics which are known as characteristics of earth magnetism or magnetic elements. Before going to magnetic elements, let us define geographic meridian and magnetic meridian. Geographic meridian. What does it mean by geographic meridian? What is the meaning of geographic meridian? Remember the definitions. These are very important from examination point of view. You may be asked to define geographic meridian or magnetic meridian. It is defined as the imaginary vertical plane passing through geographic north-south of earth. Geographic north-south of earth. It is defined as the imaginary vertical plane passing geographic north-south of earth. The geographic meridian. Magnetic meridian. What is the meaning of magnetic meridian? Magnetic meridian of how to define magnetic meridian of earth? It is also defined as the imaginary vertical plane passing through magnetic north-south of earth. It is defined as the imaginary vertical plane. The definitions are important. Imaginary vertical plane passing through magnetic north-south of earth. Magnetic north-south of earth. So geographic meridian and magnetic meridian of earth are defined. Now we will go to what are the characteristics of earth magnetism, which are known as magnetic elements of earth. They are very important. Magnetic elements of earth. Magnetic elements of earth. Magnetic elements of earth. Earth magnetism is characterized by three characters which are called magnetic elements of earth. The first characteristic is declination or variation. Declination or variation. The symbol is theta. Declination or variation. Remember the definitions. Declination or variation. What does it mean by declination? Declination at a place is defined as the angle between geographic meridian and magnetic meridian of earth. Declination at a place is defined as the angle between geographic meridian and magnetic meridian of earth. Magnetic meridian of earth. This is your declination or variation. Next characteristic is very important. Deeper inclination. Second element, deeper inclination. It is denoted by delta, deep or inclination. How to define deep? It is the angle between the resultant intensity of earth and the horizontal line, or in the direction of horizontal intensity. It is defined as the angle between resultant intensity resultant intensity of earth and a line in horizontal direction, angle between resultant intensity of earth and line horizontal direction, delta. It is maximum, remember this, maximum at the poles, that is 90 degree, and minimum at the equator, that is 0 degree. So deep is maximum at the poles, value of deep at the poles is 90 degree, and at the equator it is 0 degree. And the last element is third element, that is horizontal intensity. Third element, horizontal intensity. Symbol is what? Symbol is H. It is defined as the component of earth magnetic field in horizontal direction. It is defined as the component of earth magnetic field, in horizontal direction, Define the component of earth magnetic field in horizontal direction. Then we explain diagram by diagram like this. This is your magnetic meridian. This is your geographic meridian. A, B dash, C dash D. This angle is theta, that is your declination. The resultant intensity of earth magnetic field R. This is horizontal component H, this is vertical component V, and this angle is the delta. They are a deep angle delta. So the diagram is like this. So your H becomes what? What is H? R cos delta. What is V? R sin delta. All these things are explained in the diagram. Magnetic meridian, geographic meridian, angle between theta, resultant intensity of earth R, horizontal direction H, angle dp is delta. So H is equal to R cos delta, V is equal to R sin delta. So H square plus V square is equal to R square cos square delta plus R square sin square delta. That is equal to R square. So what is the resultant? S square plus B square root over Z. Similarly, if we divide V by H, R sin delta by R cos delta, that is equal to tan delta, or delta is equal to what? Tan inverse V by H. that the deep angle. So this is all about your earth magnetism. So the portions which are in the syllabus in magnetism are all covered. Magnetic substance, different properties of magnetic substance, dia, para, ferro, etc. Magnetic field end on position, broadside and position, long questions, short questions are all discussed. In the next class, we will proceed towards magnetic effects of electric current. How a conductor carrying electric current behaves like a magnet associated with a magnetic field. That is very important. That chapter is very important from example point of view. You will get a long question from that chapter as well as short questions from that chapter also. So let us stop here.